Black holes are one of the most interesting topics in astrophysics. You may have come across this term many times, but most people don't know what they actually are. Today, we will be telling you what black holes really are. Now, let's get to the theory part, shall we? The term black hole is of very recent origin. It was coined in 1969 by American scientist John Wheeler. To understand how a black hole might be formed, we first need an understanding of the life cycle of a star. A star is formed when a large amount of gas, mostly hydrogen, starts to collapse in on itself due to its gravitational attraction. As it contracts, the atoms of the gas collide with each other more and more frequently and at greater and greater speeds. The gas heats up. Eventually, the gas will be so hot that when the hydrogen atoms collide, they no longer bounce off each other, but instead merge with each other to form helium atoms. The heat released in this reaction, which is like a controlled hydrogen bomb, is what makes the stars shine. This additional heat also increases the pressure of gas until it is sufficient to balance the gravitational attraction, and the gas stops contracting. It is a bit like a balloon where there is a balance between the pressure of air inside, which is trying to make the balloon expand, and the tension in the rubber, which is trying to make the balloon smaller. The stars will remain stable like this for a long time, with the heat from the nuclear reactions balancing the gravitational attraction. Eventually, however, the star will run out of its hydrogen and other nuclear fuels. And paradoxically, the more fuel a star starts off with, the sooner it runs out. This is because the more massive the star is, the hotter it needs to be to balance its gravitational attraction. And the hotter it is, the faster it will use up its fuel. Our sun has probably got enough fuel for another 5,000 million years or so. But more massive stars can use up their fuel in as little as 100 million years, much less than the age of the universe. When the star runs out of fuel, it will start to cool off and so to contract. If a star's mass is less than the Chandrasekhar limit, it can eventually stop contracting and settle down to a possible final state as a white dwarf with a radius of a few thousand miles and a density of hundreds of tons per cubic inch. A white dwarf is supported by the exclusion principle, repulsion between the electrons in its matter. We observe a large number of these white dwarf stars. One of the first to be discovered is the star that is orbiting around Sirius, the brightest star in night sky. As the star contracts, the gravitational field at its surface gets stronger and the light cones get bent inward more. This makes it more difficult for the light from the star to escape, and the light appears dimmer and redder to an observer at a distance. Eventually, when the star has shrunk to a certain critical point radius, the gravitational field at the surface becomes so strong that the light cones are bent inward so much that the light can no longer escape. According to the theory of relativity, nothing can travel faster than light. Thus, if light cannot escape, neither can anything else. Everything is dragged back by the gravitational field. So one has a set of events, a region of space-time from which it is not possible to escape to reach a distant observer. This region is now what we call a black hole. Its boundary is called the event horizon. If you look at a black hole, you will actually see the event horizon, as black holes do not allow the lights to lights to get out of them, so you will be eventually seeing the event horizon. According to the general relativity, there must be a singularity of infinite density within the black hole. This is rather like the Big Bang at the beginning of time, only it would be an end of time for the collapsing body and the astronaut. At the singularity, the laws of science and our ability to predict the future would break down. However, any observer who remained outside the black hole would not be affected by this failure of predictability, because neither light nor any other signal can reach them from the singularity. Now you may ask, what does this singularity look like? Well, we don't actually know, but what we know is that if you end up anywhere near a black hole or a singularity, you would be stretched until you are wiped out of existence. That is not quite pleasant. After learning about black holes, most people wonder what would happen if someone fell into one. A short answer to that question is he would die. I will talk about this in more detail in the next video. For now, thank you for watching.